Number 1, mean value theorem.
Okay. Okay. Rolle's theorem states that if I have, okay, it's easier for me to, I have to draw it out before I can.
Draw whatever you need to. Just explain what you need to explain. Go ahead.
So Rolle's theorem says that
examples, and the drawings are all there. But I want to break them down into the actual wording and why they are the way they are, okay? Mean value theorem. The word that you want to think of mean is your average, right? There's an average value. Okay? So what that means is that from the beginning to the end, let's say for today, I'm going to hike to the top of a mountain, top of Mount Everest, okay? And so I'm just going to draw a funny graph from, okay, let's say I go and we go and, you know, okay, and I hike up there, okay? So I can give you an average slope for the entire trip, okay?
Okay.
What the mean values theorem states is that the average for the whole thing must exist somewhere in the middle, okay? At least one time, meaning that if anything, if it were really easy, the entire hike would just be this entire thing the whole way.
Yes.
However, if I were really to look closely, there's a spot where that was exactly the hike, maybe where I went over, and here's another one, here's another one, here's another one, okay?
It just says that there's some value. See, it doesn't tell us where that value is.
Yes, it just says that if I were, another good example is to say, if today your mom was on the highway and went an average of 50 miles per hour total, okay, of her driving everywhere, okay? An average of 50 miles an hour. Does that mean at some point along the drive she had to have gone 50 miles an hour?
Yes. It does.
Yeah, because physically it'd be impossible. Let's say if she was always under 50, it would never be 50 as an average. If she was always over 50, it would never drop low enough to be 50. So you have to go across that number somehow mathematically. Does that make sense? Okay, so another one is to say, like, okay, over the course of this, what was the sport that you like?
Tennis.
Tennis. Let's say over the course of Roger Federer's tennis season or tennis tournament, he had a certain average points per game. Does that mean at some point he scored that many points in a game?
Well, I mean, strictly speaking, no, but I get the point.
Right, I know I might have messed up the way tennis works in that sense, right? But you understand, right? Let's say Kobe Bryant shoots and scores 20 points a game. That means he had to have more than 20 at some point. If it was 21, then he had 19 one, right? If he had 22, then he had 18 at one. And it always has to average itself out. So the average value must exist in between if that is the overall average. Okay? So what does intermediate mean? You got beginner, intermediate, advanced is the one in between, okay? So what that means is the way that you had drawn this is nice, and it's actually pretty good, but I like to make it a little bit tougher. Let's say these are our stocks, okay? You start with $100 and you end up with $200, but this is what happens to your money, okay? If you know that your range from A to B is 100 to 200, you can assume you have values in between them. You can't make assumptions about these guys. There's no, you can't assume that they exist. But you do know, right? If yesterday you had 100, today you had 200, at some point you had 101, at some point you had 102, 103, 103.05637894. Do you see that? Every number along that from 0 or from 100 to 200 had to exist. Otherwise, physically, it would be discontinuous. Do you see why continuity is important?
Yes.
Continuity is as if on your hill, there's no cliffs you fall off of, right? There's no end to a path.
Yeah.
For continuity for money, it means like, I mean, your money's still moving and growing and things like that, okay? Rolle's theorem. But I want that explained in a manner that we could use for our world.
Okay. if I'm on a roller coaster and I start and end at ground level, at some point it must have stopped going up, and I haven't started going down yet, and so that's the point where the slope.
Exactly, perfect. If you are at any point where the two values are the same, you started and ended up at the same value, unless it was just a straight flat ground in between the two. If you went up, you had to come back down. If you went back down, you had to come back up. So there has to be, just like the mean value theorem, the overall slope of the entire thing must exist somewhere. So that's to say, if I went from here and I hiked to somewhere else, and it's the same elevation, I had to either go into a valley somewhere or I had to go up on a hill and come back down. That make sense?
Yeah.
If I went 100 miles an hour on the highway and I'm going 100 miles an hour on the highway later, that speed had to have gone up and had to have gone down and had to have turned back around to meet back at 100 at some point. That make sense?